Today I will be explaining the design issues in the network layer, a, a key layer in the OSI model that plays a big role in sending data across networks. Networks is connected with routing of packets from the source to the destination. To achieve the goal, the networks layer must know about the topology of networks. The networks layer is majorly focused on getting packets from the source to the destination, routing, error handling, and conjunction control. The network layer is a layer 3 in OSI model. Its job is the move data called a packet from one device to another. Possible access my network. While doing it is also to has you also has to detect and handle any error that may occur. Avoid network congestion which can slow down communication. This part talks about one of the most important job of the network layer, routing. It decide the best path for to travel through. To do this correctly, the layer needs to understand the network's topology, or in simple words, in layout or map of how all the devices, all routers are connected. Before learning about design issues in the network layer, let's learn about its various functions. First, addressing, second, packetting, third, routing, fourth, internetworking. First is addressing. Maintenance, maintenance the address at the frame header of both source and destination, and perform addressing to detect various devices in the network. Second, packetting. This is performed by Internet Protocol. The network layer converts the packets from its upper layer. Routing. Third is routing. It is the most important functionality. This device, the network layer choose the most relevant and best path for the data transition from source to destination. Fourth is internetworking. It works to deliver a logical connection access multiple devices. The network layer comes with some design issues that are described as follow. Store and forward packet switching. First, second, services provided to the transport layer. Third is implementation of connectionless services. And fourth is implementation of connection-oriented services. First, store and forward packet switching. The host sends the packets to the nearest router. This packet is stored there until it has fully arrived. Once the link is fully processed by verifying the CHOM scheme, then it is forwarded to the next router till it reaches the destination. This machine is called a store and forward packet switching. In stored and forward packet switching, a network device like a router receives an entire package, stores it's a buffer, and then forwards it to the next device after verifying its integrity. This process ensures data package integrity and allows for error checking before forwarding. A diagram of store and forward packet switching. H1 is the source host where data is generated, process P1. H2 is the destination host where data is received, process P2. The oral area represents a network of routers A to F. The packet travels from H1 through routers A, B, D, E, R, finally to H2. receive the entire packet, store it in memory, examines the destination address, forwards it to the next burst router. Let's assume we want to send a file from computer H1 to computer H2. The file is divided into small packets. Each packet is sent to router A. Router A stores the packet, checks the address, the forwards it the router B. This process continues A, B, D, E, F and H2. At H2, all packets are assembled from the original file. Second is the services provided to the transport layer. Through the network transport layer interface, the network layer transfer its pattern services to the transport layer. Those services are described below, but before providing those services to the transport layer, the following goals must be kept in mind. Offering services must not depend on router technology. The transport layer needs to be uh, protected from the types, number and topology for the available router. The network address for the transport layer should use inform numbering patterns also at LAN and WAN connections. Based on connections, there are two types of service provided. First is a connectionless, second is a connection oriented. First, connectionless is the routing and interact and insection of packets into the subnet are done individually, no added setup in required. Connection oriented is subnet must offer reliable service and all the packets must be transmitted over a single router. The diagram of transport layer. A computer, a computer on the left and a service on the right. Both are connected via the internet network layer. Above the internet, we see process on both sides. This represents how data is sent from a process on one devices, for example, a browser. It processed through the transport layer which phrases it. It is submitted over the internet. It is transmitted over the internet. The transport layer on the receiving device resemble the data. Finally, it is divided to the correct process. Example, a web server app. Third is the implementation of connectionless services. Packets are uh, trembled as a datagrams and corresponding subnet as a datagram subnet. When the message size that has to be transmitted is 4 times the size of the packets, then the network layer divides into 4 packets and transmit each packets to the router via a few protocols. Each data packet has a destination address, is routed independently irrespective of the packets. The diagram of implementation of connectionless services. Uh, Understanding the diagram, let's walk through the part of the diagram on your side. Devices of process P1 sender, process P2 receiver, connected through a network of routers labeled A, B, C, D, E, F, etc. Packets are sent from P1 to P2. Each packet travels independently, meaning they don't all follow the same path. For example, one packet may go A, B, D, F, another may go A, C, E, F. How it is work? P1 sends packet to P2. Each packet is forwarded immediately through routers. Routers check their routing tables in decide the best next hop. No, no guarantee, no guarantee that packets take some path or arrive in order. P2 receive all packets and resemble them if needed. Fourth is implementation of connection-oriented services. To use a connection-oriented services, first we establish a connection, use it, and then release it. In connection-oriented services, the data packets are delivered to the receive in the same order in which they have been sent by the sender. It can be done in either two ways: circuit switched connection and virtual circuit switched connection. Circuit switched connection is a detected physical path or a circuit is established between communicating nodes are then the data streams in transferred. Second, virtual circuit switched connecting. The data stream is transferred over the packet switched network in such a way that it seems to the user that there is a detected path from the sender to the receiver. A virtual path is established here, while other connections may also be using the same path. The diagram of implementation of the oriented services. It is a simple diagram, same of the implementation of connectionless services. Connectionless vs connection-oriented. Both connectionless and connection-oriented services are used for the connection establishment between two or more devices. Those types of services are provided by the network layer. First is the connection-oriented services and second is connectionless services. First is the connection-oriented services. In connection-oriented services, we have to establish a connection between sender and receiver before connection. Handshake method is used to establish a connection between sender and receive. Connection-oriented services includes both connection establishment as well as connection transmission phase. Real-life example of this service is a telephone service or connection. We have to first establish a connection. Second, connectionless services. In connectionless services, no need of connection establishment and connection termination. This service does not give a guarantee of reliability in the service. Packets may follow the different path to the reach their destination. Real life example of the service is postal system, online gaming, real time video and audio streaming. Thank you.